Okay, number 7, part A. Solve the equation 8x squared plus 6x minus 5 equals 0 by factoring. So since this quadratic has a leading term that's not 1, I'm going to multiply the leading term times the constant and get negative 40. So I'm looking for a set of numbers that multiply together to be negative 40, but at the same time add together to be negative 6. And those numbers would be negative 10 and 4. So those are going to go in these two diagonals with an X on them. Then the leading term, 8x, will go in this diagonal, 8x squared. And the constant term goes in this diagonal. Okay, now what I'm going to do is the GCF to each row and to each column, and that's going to give me the terms that are in the two binomials that are going to multiply together to make this thing equal to 0. Or factored it, I'm sorry. So when I do my GCF, so I got a negative 10x and a negative 5. So the GCF is 5. Since this first one has a negative, a leading negative, I'm going to pull out negative 5. Okay, these two, the top row has 4 and an x, so I can pull out 4x. So I know what my first binomial is, 4x minus 5. Okay, now I'm going to do the columns to get my other binomial. So between 8x squared and negative 10x, I would have a 2 and an x. And between 4x and negative 5, the only common factor would be 1. So this is going to be 2x plus 1. And if you're not sure that you're correct, if you just FOIL this, 4x squared, 4x times 2x is 8x squared. Okay, 4x times 1 is 4x. Negative 5 times 2x, negative 10x. Negative 5 times 1 minus 5. And then those two are equal to 6x. So it's back to what it was originally. So you know you got your right set of factors. All right. Now, to solve it, we take each one of these and we set them equal to 0 and solve it for x. So I'm going to have 5x minus 5. What makes that 0? And then I'm going to do the 2x plus 1 and see what makes that 0. Alright, so what I did here then is I went ahead and did my GCFs, factored it, got my two binomials, set each one equal to 0, and then solve for x, and I get x is 5/4. Solve this binomial equal to 0, and I get x is negative 1/2. So that is my two roots for this quadratic. All right, part B. All right, part B. Determine the range of values of k for which 8x squared plus 6x minus 5 equals k has no real solutions. All right, so for something to have no real solutions, its discriminant has to be less than 0. All right, so I'm going to take this equation here and get it equal to 0 first, and then plug in the values for A, B, and C. into the discriminant. So I'm going to have to subtract k from both sides first. All right, now I'm going to take my values of A, B, and C. So A is equal to 8, B is equal to 6, and C is negative 5 minus K. So I'm going to plug those now into my discriminant above, and I'd have 6 squared minus 4 times A times C. All right, so inside of here I'm going to get 32 times C, and then that's going to give me 32 times 5, 160 negative, minus 32 times K, 32K. And then I got 36 out here. Now that 36 affects everything, or that negative affects everything on the inside. So this becomes 36 plus 160 plus 32K. Because all I did was distribute that through. Okay, so that's 196 plus 32K, and I want all of this to be less than or equal to 0. All right, so now we take our inequality and we solve it. It's a linear inequality, so we don't need to make a sign chart. We just solve it for K. So I move the 196 over to the right side, and I get 32K is less than 196. Then I divide both sides by 32. And I get K is less than negative 196 over 32, and then each one of those is divisible by 4, and I get it reduced to negative 49 over 8. And that is number. All right, number 8. The height H in meters above the water of a stone thrown from a bridge is modeled by the function ht, where t is the time in seconds after the stone is thrown. Find the initial height from which the stone is thrown, then find the maximum height, then find the amount of time it takes for the stone to hit the water below the bridge, find the domain of h in the context of this real scenario, and then find the length of time for which the height of the stone is greater than 23 meters. Now, this could be done by hand algebraically, or it can be done on your calculator. This symbol here indicates use your calculator to solve this problem. So for part A, we can pull that right from our equation. All right, our C value is 18. So that is our initial height. It's the same as the y-intercept. Okay, so for part A, the initial height is the y-intercept. Okay, part B, find the maximum height. Well, the maximum height is going to be the y-coordinate of the vertex. So we're going to graph it, use the max function, and find out what the y-coordinate is of the vertex. So, all right, so I've got it input into my calculator. Now the window, I know it starts at 18 and then it's going to go higher. How much higher above 18, I'm not quite sure. So I'm going to adjust my window. I made my new y max 40. Okay, and you really don't need much of a x minimum because x would represent the time in this case and y would represent the height, and you can't have negative time. So I'm just going to make that like -2, and I'm going to do the same on my y because you can't go below 0. It can't go below the ground. The ground would be at 0. Okay, now we'll graph that and see what she looks like. Okay, so there's our graph. And we didn't really need to go out too far on the x's, so just so I can get a little bit better look, I'm going to change the x max to like 10. There we go. And spread it out a little bit. Okay, so we want to find our max now. So I go second, calc, choose number 4, max, and I want to put the cursor to the left of the vertex. Enter. Right of the vertex. Enter. And then about where I think the vertex is. Enter. And my maximum is the y-coordinate. So I now know for B, my maximum height is the y-coordinate of the vertex, which is 26.2622, etc. So I'm going to write my max height to 3 sig figs would be 26.6, and we're working in meters. Okay, so we got our first two answers. We got A, initial height, 18. And then our max height is the y-coordinate of the vertex, which was 26.2. Okay, part C. All right, find the amount of time it takes for the stone to hit the water below the bridge. So that would be the same as this x-intercept. So I'm going to go back to my calculator and use the 0 function and find out what that x-intercept is. So second, calc, part 2, 0, and I want to do the one over here. So left bound is before the x-intercept, Right bound is after the x-intercept. And my guess. And there's my x-intercept, 3.66 seconds if I round it. Oops. Okay, so there I found my other 0. At 3.66 seconds it hits the ground. All right, write down the domain of H in the context of this real-life scenario. Okay, so the domain of H, okay, the domain is made up of is time. All right, because time is your x-axis. All right, so down here, this formula, the independent variable, that's what's inside the parentheses. That is your x values. So in this case, that's time. Well, the domain, if we're working with a projectile, you can't have negative time. So our domain is going to include 0, because at 0 it's 18 meters above the ground, and then it is going to hit the ground at 3.66 seconds. So you'll never have an x coordinate larger than that, because then it would be below the ground, which wouldn't make any sense. Or I guess in this case it's not below the ground, it's actually below the water. Okay, so it could go below the water, but since it's asking us when does it hit the water, we're considering that to be the end of the problem. Okay, now for E, it says find the length of time for which the height of the stone is greater than 23 meters. So if we're doing this on our calculator, we're going to find the x values where the y values are 23 meters or greater than 23, so not equal to 23. So really what we're solving here is when is 18 plus 13 minus 4.9 t squared greater than, not equal to, but greater than 23. So to do that on our calculator, one way to do it is to draw a horizontal line at 23 meters and see where it crosses. So I'm going to go to y equals, go down to y2 and put in 23. Okay, and we'll graph that and we get that intersection. All right, now what we want to find is what's the x value of this intersection. That's going to be the time that it starts to be over 23 feet. And then what's the x value of this second intersection? And then between those two x values, or t values, is the time that it is greater than 23. And since it says the length of time, we're going to subtract those two. So on my calculator, I've graphed my line, y equals 23. Now I'm going to go second calc, and I'm going to go to intersect. So that's number 5. Okay, and it asks me questions. It says put the cursor on the first curve that you want to find the intersection of. Well, there's only 2 curves on here. One's a straight line and the other one's a parabola. So up here on the top, it's showing me that right now the cursor is on the parabola. So I want to choose the parabola, And now the cursor is on the second curve, which is the straight line. And now I want to move the cursor to where I think the intersection is, which is going to be about there. So I hit enter, and my intersection is at 0.4667, and I would round that to 0.467. So that's my first x coordinate. Now for my second x coordinate, I do the same thing. So second calc, intersect. Okay, it's on the parabola right now, so enter. Now it's on the line, enter. And now move it to where my other x or intersection is, enter. And there's the other intersection where at 2.19 seconds it would be at 23 meters. All right, so if I rounded each one of these to 3 significant figures, the first time that it's at 23 meters is going to be at 0.467 seconds. And then the second time that it's at 23 meters is at 2.19 seconds. And then I'm going to subtract those two amounts. So I subtract those and get 1.723, and then round that to 3 significant figures, and the amount of time that is 23 meters, above 23 meters, would be 1 and 72 hundredths of a second.